everybody, my name is Sally-Ann Spence and welcome to the Hills Quarry Products dig site in Cernywick. Now we have an amazing amount of things coming from this dig. We've got material that's both Ice Age and Jurassic, and it's possibly the biggest paleontological dig that's going on in the UK right now. So lots happening, but as we're part of a big quarry complex, we are unfortunately not able to have visitors on site. However, we are doing these videos live and unedited, pretty raw from the field, so that you can enjoy the dig with us. And I've got various people coming up here to talk to me, and one of them who's been taking part in the dig is Ben Cunningham. Hello, Ben.
Hi, Sally-Ann. Thank you for having me.
Well, it's great to see you, Ben, because you have been on this dig for 2 years in a row now. And you've been amazing about going around the camp, not just doing the digging, but you've been doing so many other jobs. Can you tell us some of the other jobs you've been doing?
Oh, so as part of the activities and operations organizer, I've helped make sure everyone topside is all catered for and all okay. And I also make sure all the operations down on the quarry side, so all the teams have the right tools, they're all happy of how the excavation is going, and making sure there's clarity between topside and the quarry, as well as organising all the evening events to make sure our happy campers are happy.
Exactly, because this is a 3-week dig and we're on the final week. And everybody has been, well, most people have been actually living in a tented village behind me, and that's quite a lot to look after, isn't it?
Yeah, especially when they've been working. We have very hard workers on site, and they work all week, for some of them for 3 weeks straight. Yeah. So it's important that they get their leisure time and their breaks, and make sure you chase people up on that.
Exactly. And then in the evenings we have other specialists coming in on site, who are doing lectures, which vary hugely from futuring your career and your CV and all that rest of it, to, I think, what did we have last night?
Oh, so we had the history of spectrometry and how it's developed over the years. And we've also had the Yorkshire fossil hunter, Mark Kemp. Hopefully you've got him on camera.
Yes, we've got Mark.
Perfect.
45 minutes of Mark, I think. Do watch the videos though. We've been uploading videos constantly. And Mark talks all about preparing fossils and things like that.
Yes,
so yeah. No, he's very entertaining. So tell me then, Ben, you are studying paleontology.
Yes, so I study Palaeontology and Evolution at Bristol. I'm going into my 3rd year. And I'm also part of the research interns there as well. So I get to go about the lab space as well. So that's really good to do my own research as well. And hopefully some of the stuff from this dig can help complement my research as well.
I was going to say, you have actually brought a whole load of things with you.
Yes, I have.
So we are going to go through these. But first of all, I'm just going to let you know that, as I said, everybody has to take part in something while they're here, not just the digging. And this is a scientific dig, so we are actually looking for data much more than specimens in many ways. It's all about the data of the whole of the geology as well as the paleontology. Now, if you're in taking part, as I said, you have to do various other jobs like cooking,
yes,
and the toilets or anything, to make sure it's all clean, change the toilet paper, all those sort of different types of jobs you have to do. And one of the jobs we try and get everyone to do is take part in helping us do these films. And today we've got, who have we got today? I'm just trying to say, oh, we've got Emily. Emily's on camera, so she's going to be bringing the camera in and showing you. So go ahead, Ben, let's have a look.
Perfect.
And Emily, you're in charge of the camera.
So today we're looking at one of the most common mollusks you can find on site. They aren't Gryphea, which hopefully you nab someone for a talk. That's a big thing to tackle though. However, we're talking about belemnites here and the different belemnites we have on site. So belemnites are a group of cephalopod, so that includes both the nautilids. So I don't know if you've ever seen a nautilus before, but these lovely spherical shells, very ornate. They go for great shelving pieces if you ever find one washed up on the beach. And there are some magnificent animals with some awesome camera-style eyes. We also get the ammonites, which are an extinct group that also are alongside the belemnites. So here's an ammonite here, and we'll get into that later. And then you also have the coleoids, which include the octopi, the squids, and the cuttlefish.
Okay.
And so the belemnites are actually within this group as well. They are extinct, unfortunately, but they emerged during the beginning of the late Triassic, so over 200 million years ago. And they've lasted through the Jurassic, which is now, and they even go into the Cretaceous. And so here's one of the most common belemnites we have on site here. So this is a Cylindrotuphis, and they are essentially what preserves is the hard parts, and this is the guard of a belemnite. Oh, don't drop it. Luckily, and what I was going to say is it's a hard calcite, so that's why it does preserve, demonstrated by my dropping it. And aside from to contrast the ammonoids, so the ammonites and the nautilids, they can actually internalise their hard parts. So a bit
Alright.
like how squids, I don't know if you've ever dissected a squid before, but if you cut some calamari up, you'll actually find a squid pen, which is a very plasticky form of shell. It's the residuals from their shell. But back in the past, their ancestors, including the belemnites, had a hard inner shell. And essentially what it provides, I don't know if you can see this hole in here.
Oh yes, yes, you can see that. We'll get the camera back in. Thank you, Emily. So this is the which end of the animal is which?
So this is the tip of, so the belemnite anatomy, this would be the guard, and it's at the very tip of the belemnite. It's internal. You can actually find, this specific species is Cylindrotuphis, and you actually find blood vessels preserved on the surface.
Oh wow.
So
that's the end
that's
of the
the end,
belemnite,
yes.
and this is the business end.
Then you have it connects to the mantle cavity, which controls all the muscle control, and it interacts with buoyancy, which I'll get into in a second as well. And then you also got the head of so you've got the beak and the tentacles of the belemnite on this end. And belemnites, or at least the true belemnites, their guards are about 1/3 of the length of the entire body. So this animal is probably about that big. So he's a very large animal.
Do you know, I didn't know that. That's actually quite big, because often when we see them, I'm assuming, I always thought they were quite small around it, but they're not. No. That's huge. Do that again then.
Huge. So if this is 1/3, so it's missing a couple millimetres or a couple centimetres.
And possibly a bit more.
Potentially a bit more. Lucky it's going to the phragmocone, which I'll get into in a second, so we know it's near the end. Then you have the mantle cavity and the head. So that's about 1/3, or maybe yeah. So it's a huge animal. It would have eaten fish and any other small critters, smaller than it really. And we can tell it's Cylindrotuphis mainly because they have a very signature tooth furrows, and I might be able to explain it better with that specimen over here.
Okay.
So, because they have tooth furrows.
Emily's got her work cut out today.
Yeah, I know. So it would have split along there, and because the tooth furrows make a planar weakness, often these belemnites split in the middle quite cleanly. This is the tip. You can't actually see the phragmocone come into here, and I'll get into that in a second. And so, there you go. Hopefully that's a good enough angle.
Yeah. Yes, I see.
Perfect. And then if I borrow the other specimen.
There we are. There's that one there.
So the outer guard in true belemnite specifically is calcite. So you can see there's this hard bit of calcite here. But internally, there are these little infilled chambers. So these would have been hollow in life, and around them is a weaker calcium-containing mineral called aragonite. And that's that white powdery stuff you see on the outside. And what would happen is, let's see if I can find the angle here. There are very minute dots here because this was a relatively small belemnite.
Are we picking these up, Emily? Can you get these?
Yep.
Yeah, brilliant.
So the mantle cavity in the musculature is able to pump water through this siphon, is what we call this tube, the little dots along the side. And so that controls how much air is in these chambers and how much water is in these chambers, so they can maintain neutral buoyancy or change where they are in the water column.
Okay.
And you can even see that some ridges on this one as well. And so it inserts, actually, I can probably show you this from far away. Two different animals, but you can see how they might connect.
Right, okay, I'll carefully put that there.
So that's one group of belemnites. And actually, you can kind of see it quite clearly here if you want to come over again.
Oh.
Sorry, Emily.
Well done, Emily, you've got your work cut out.
So you can see along this outside, here's the other half. There is the calcite outside, and then there is the aragonite layer, and you can kind of see the chambers begin in this phragmocone here. This is a lovely specimen.
That's beautiful, isn't it? Absolutely beautiful. That's stunning, in fact. Yes.
And then we also have another rare and obscure group, which is this group, and they're called the belemnituphids. This is an acanthoteuthis. And so I'm throwing a lot of big words out right now.
You are. You're throwing them all out. That's great.
So this is a type of belemnite called a belemnituphid, and they are a group of belemites that don't have the calcite outside. So this one specifically is acanthoteuthis. And so instead of having a large calcite chamber, they only have an aragonite and a very thin film of calcite, which doesn't preserve very well. So you can see this one, you can see no trace on the sides here of a calcite chamber on the outside.
Oh, I see, yes, okay.
And so they aren't true belemnites, even though they often are mistaken for just another phragmocone, which is the name of this ridge structure.
Because belemnites are one of those fossils that a lot of people pick up alongside ammonites at places like Lyme Regis, you know, the place where everybody goes. And as you said, they're very hard and they preserve very well.
Yes, yeah.
Quite not always easy to find them as big as this, so as complete as that.
Yeah, Cylindrotuphis is quite famous for being quite a large and well-preserved belemnite. And honestly, these are some remarkable specimens we find here on site. Usually they're little dinky, bullet-shaped belemnites. You can also find a lot of soft tissue preservation. So on, say, the Cylindrotuphis, we don't have any soft tissue preservation on this, but there are two ridges and an indentation here. This would have been the top side and bottom side, and I actually don't know how to tell the difference actually between top and bottom. But I do know that the lateral side, so either side of it, that's where the cartilage fins would be. So it's a bit like a
see.
yeah. So if you run your finger over that, there is a very subtle ridge in the middle of this.
Emily, I don't know if you're going to be able to pick this up, but we'll try.
Yeah,
we'll try and see if
You'll
we
have
can
to
share
trust
this
us
with
if
you.
not.
Yeah. So go on, Ben.
So there's a ridge going along the side of it right here.
It's very flat.
It's very flattened.
Just there. Can you pick that up at all? If we just tweak
Maybe
it a little
I'll
bit.
twiddle it around.
So it's very round here, oval, and then it just goes to a flat bit here.
Then I'll probably pick it
Same
up.
on
You
the
might be
other
able to pick
side.
it up here.
Or can you pick that up a little bit easier? Just that bit there.
Yeah, a little bit of a sheen,
Do
change
you know,
in sheen.
I've never noticed that before. Now you've pointed that out. I shall notice that everywhere.
Everywhere,
Thank you.
yes. Other soft tissue stuff we find is in, say, nice bits of shale. We can find the hooklets of a belemnite on the end of their tentacles, as well as their beak, of course. And actually, you can also find little ink sacs as well. And tangentially, the squid-like organisms of the Jurassic is actually how we discovered or worked out how dinosaur colour could be worked.
Really?
So ink sacs contain melanosomes, and that is what produces the pigments of melanin. And that's basically what ink is just big pockets of melanin. And when invertebrate researchers were looking at the soft tissue preservation, saw the ink sac in there, or basically you can actually see it visually. There's a big brown blob in the middle of all of its gonads and its intestines. You can see a big black blob, and so researchers was like, oh, how can we see the pigment in this big black? How can we tell it's the ink sac? So if you get a microscope on it, what's giving it that color is the melanosomes in it. And so tangentially, the researchers thought, what if we looked at dinosaur feathers or keratin that might contain some melanosomes in there as well? And so piecing that together, we can actually work out by the shape of the melanin what kind of pigments are being produced, which is how the origin of dinosaur colour started to come about. So
well,
there you go.
As I said earlier on, you know, this is a great opportunity for you to learn not only what goes on in the quarry, but learn just new things. That is absolutely brilliant, Ben.
Thank you, yeah. I mean, give the small guys a chance, because sometimes, I mean, it will help you out with very flashy projects, but also they have a lot of story to tell.
Definitely.
And I guess a little, what's the word? To hype up potentially the papers coming after the dig, we actually have a belemnituphid that we are unable to diagnose, and hopefully it cracks some records and it's an exciting find for publication. So look out for that.
Yes, definitely. That is very true. We do have a new specimen. I think we can say absolutely outright.
Oh,
it's a new
100%. It's probably a new genre at the minimum, and that's being quite conservative.
So we can't share with it
no.
right
In
now.
fact, our Jurassic team is doing wonders right now, because they've hotlisted half a dozen new species already. So
yes, because you've been part of that team actually, haven't you?
Yeah. So
it's looking pretty good, isn't it?
Yeah, but we're keeping it a little bit hush-hush just to hype up the work that's going to be done on it.
Yeah, so as I said, it's a 3-week dig, but at the end of the last day, it does not stop. That's when the actual work on another level really starts, and there's going to be a lot of papers coming from this, so it's fantastic. Ben, you have been amazing. Thank you so much for telling us all about the belemnites that we're getting from the quarry.
Hopefully you've learned a bit from these fellas.
Yeah, have you dug any up?
This is the one that I actually dug up.
Oh, that is a superb example.
Yeah, actually, because it's so dense in calcite, even though calcite dissolves in very weak acid, off-site I generally soak them in acetic acid, and it basically clears off all that top cement that you might find on, say, some of these. And so you can actually see all the details of anatomy. So it actually lets me talk about this here and talk about it with any visitors that might have an interest in belemnites.
Because it looks polished.
It does look polished.
Stunning.
And all it is a very, very light soaking in what is essentially vinegar. And it just removes all of the bit of calcareous cement around it.
Well, thank you very much, Ben, for telling us about these. So do keep watching the videos. We are uploading all the time, loads of information, and plenty of time for you to go and look at the dig itself. I will be taking the camera down there. I already have, and we've been finding all sorts of amazing things. So keep following these videos. Have a look back at some we've already posted, and the hashtag is TussForce.